Green Coat. So that is our general brand name for the color coated materials, and those materials which are actually designed and meant to be top of the art of these building materials. And of course, Green Coat name includes also eco-consciousness, and I'm also telling a little bit about that side. Not only that we have the world's cleanest steel already, we have focusing on more and more to these environmental issues, and our very big target and task is to be first in fossil-free steel. Maybe some of you have already noticed beginning of this year that we have introduced widely our plans for next years up to 2030, and we are building our production system so that we will be producing fossil-free steel already 2026 and totally end of 2030. So that is really remarkable goal in our production and strategy. Green coat material, we have also many coatings which are marked with the BT letters, and this BT means bio-based technology, and behind that technology there is amount of bio-based solvents and based on bio-based oil which has been used for the solvents in the paint. So the coatings which are including this technology are marked with these letters B and T. So about the eco-consciousness and things around it, of course, there is recycling and recyclability of the material as well. And we already have got several different kind of certifications from the environmental systems. And here you can see, for example, Basta uh, logo in this slide. And more and more these things are coming to the building sector as well, and many environmental key figures and information you can find from our EPDs, and in the end of the presentation I will come back to that issue also. About the process itself, when we are making this color coated sheet material, we use continuous line, and the process includes several steps between beginning and end. So first place we have washing in the line, and after washing, when we have the clean surface where to start the coating, we do pre-treatment, and pre-treatment ensures the quality of the adhesion and corrosion resistance of the material. Of course, the paint layer finishes that also, and the first step in the painting is the primer coating. Uh, Normal way is to use primer coating in both sides, and then the second step of the painting, meaning top coating and reverse side coating, is in the coating number 2. And after these coatings we have oven where we cure the paint, and then we cool it down, and in the end of the line we have also continuous inspection for the material. And of course, there are several different kind of options to choose with the coatings and also the coating system. And for example, rainwater system has 2 sides with top coating, and then we have also some applications where we can produce laminated material, for example, the cold storages and so on. But for the building sector, usually it's painted material, and top coating is different with different properties, and meant for the different applications, and then we go next to those differences and similarities between the coatings. First step in that is the structure of the material, and of course the base is the steel, and then we have zinc coating both sides of the strip, and as you just saw, there is a pre-treatment before the coating, and then the primer and the top coat on the top side of the material, and the reverse side has the primer and the reverse side coating. And if there is some applications where customers need or would like to use this protective film, it's optional on the top side of the material. Many times in facade applications there is a protective film on top of the material. So why to choose this color coated material as a raw material for buildings? Of course, many different kind of aesthetics are making difference when you choose this kind of steel material, which is relatively easy to form in different shapes, and of course there is plenty of colors and surface appearances to choose, that you can achieve certain kind of outlook of the building. And nowadays we have many different kind of coatings to choose for right, right option for the certain application, meaning facade or roofing. Of course, this kind of material, when we have very long lasting surfaces and possibilities to do different kind of formings, it gives clear benefits in production and maintenance costs. And when there is a long time durability, of course this is also environmental issue when you have um, different kind of sides of sustainability noted in the application, meaning the for example carbon footprint in the production, and also the durability of the long lifetime is really big part of the sustainability. And this material is always 100% recyclable after the use as well. We have certain color palette, which is let's say basic color range, but then we have a lot of different kind of individual colors also available, and our portfolio includes quite a lot of different possibilities. And many times we have been asking we have been asked with the different color codes from for example RAL codes or NCS codes, uh, is it possible to produce in this material that kind of color, and many times it is possible. So whenever you have some special needs, you can ask it from us, and we can check if we already have the right color for your application, or is it possible to produce, and many times it is. But anyway, our basic color range has already certain colors for different coatings. So then to the applications, and we have designed many different kind of coatings for different kind of applications. And for example, roofing, we have several different options as a green coat materials, and then we have also these standard roofing coatings. Usually those are polyesters. And the premium roofing coatings, there is green coat Pural BT, both matte and gloss appearance. And then we have these tinsmith use materials, which are marked with the TSP, or in Swedish market PLX letters. And green coat TSP means the Tinsmith Pro use, and coatings Pural BT are available, and green coat TSP Legacy is the material for the applications where is needed on-site painting for the roof. And this Tinsmith use material is designed to be very formable and easy to make different kind of formings, and getting excellent properties also for the applications from the coating side, but also this fabrication of the roof is easy with this material. This green coat TSP Legacy is meant for the on-site painting, and for example it's very common in historical buildings. And this coating what we have in the material ensures the adhesion between the actual top coating paint when it's done on site. And this color is gray, but of course it will be painted very soon after the assembly. Uh, Different kind of coatings has of course different kind of technical properties, and most convenient way to find this information is to go to ssab.com and green coat pages, where you can find different coatings and their properties. Please note in this presentation that these slides are prepared just before mid-March, and end of March there was new version of EN standard 10169, which is a material standard for these color coated materials. And now there is a couple of new things in this standard, and for example this UV radiation resistance class, there is now new classes RUV5 for uh, different uh, properties and demands in testing. And in practice, it means longer outdoor testing time to ensure this resistance class for the UV radiation. And also corrosion resistance class, there is new RC5 plus. And nowadays, for example, in this green coat Pural BT, we can achieve RUV class 5 instead of 4, because this is the um, table from the time before the new standard. And also green coat Pural BT matte appearance coating can achieve corrosion resistance class RC5 plus. In practice, the difference is double the time in the outdoor testing, up to the 4 years. Just a comparison between green coat Pural BT and polyester. For example, when we have standard coating, of course, the material properties are standard, not premium. And maybe the most difference you can find from the UV radiation resistance class and corrosion resistance class, but also minimum inner bending radius when you think about the formability of the material. In polyesters, it's 3 times sheet thickness. And I will jump back to the previous slide to show you the difference between the green coat Pural BT and its 1 times inner inner bending radius, 1 times thickness. So there is a clear difference also in formability. For the facades, we have special green coat hierarch coating, which is designed for this kind of use, and it has excellent properties against UV radiation, and it keeps its color very well. Also, green coat Pural BT as a regular gloss version is possible to use in these facade applications, and then there is a standard coating, meaning the polyester, as well available in this application. Um, we have many different kind of metallic colors for these facade coatings, and especially in green coat hierarch. And there is of course many times different kind of wishes and needs, but it's very common that this application in the facades, it's made with metallic colors, and many times as well with green coat hierarch material. And if you have some application which is just next to the coastline, we have possibility to offer green coat hierarch max, which has even better properties for this kind of environment. And for the comparison, again, you can see here green coat hierarch properties. It's it's similar in the formability compared to green coat Pural BT. And now with the UV radiation resistance in this new standard, our green coat hierarch can achieve RUV5 class for the UV radiation, and the corrosion resistance is this RC4, and sign effect has this RC5. in corrosion resistance class. Then we have, of course, coatings as well, with these facade and roofing possibilities also for the rainwater systems, and this is designed for the application itself, meaning there is two-side top coat in this material, and the formability is also designed for this, even quite demanding formability properties or needs. Uh, for example, in these deep drawn parts, which are many cases needed in the rainwater systems. And nowadays we have also new matte appearance coatings available. So whenever you have some buildings where you have matte appearance roofing material, you can have it also for the rainwater systems. And when you see our material, most easiest way to confirm the material is the green coat quality. You can see the backside or the reverse side stamping and marking with our green coat text and logo. And then there is also information about the product itself, product name, production date, and the processing direction. This processing direction is also important to note, for example, in the facade applications, that you will get the uniform outlook of the facade. That means that you need to ensure the directionality of the parts. Okay, couple of examples about the architecture with the green coat material. This is application or the building which is now nominated in many awards, and it has had quite a lot of publicity already, but I would like to show it for you as well, because the application and the building is it's clear what it what it what kind of material it has been in use, and you can see the appearance. It's very unique also in the design. Couple of other examples. So this kind of material makes it possible to design very different kind of outlook, shapes to the buildings, and you still can have very easy material for these kind of purposes. And of course, different kind of use in roofs and facades, it's possible, and get a totally new kind of outlook of the building. Now we have also very different and new way of using Corten material in facades. Uh, Ruukki Construction released last year new product called Ruukki Patina, and that is a facade made of Corten steel. So these are sandwich panels which has Corten steel in outside, and you can find more information from ruukki.com, and this is totally new way to use this material, and makes uh, or let's say opens new possibilities with the sandwich panels and Corten. So totally unique way of using this Corten steel material. I already mentioned about the information in the environmental product declarations, and also other green coat information you can find from our website. And there is a lot of information about our fossil-free steel and hybrid project, which is aiming to this fossil-free steel. And of course, this PT Technologies information is also there, and many cases customers are asking us these EPDs for the building purposes as well. So those are also available in our website. And also Ruukki Construction has their own EPD for the products which have been fabricated from the color coated material. So you can also find that kind of EPD from the Ruukki Construction web pages. So short uh, overall of the presentation, what kind of reasons there is to use green coat material for the buildings. So please ask us whenever you have different kind of needs for the colors and coatings, and we will find you the suitable combination. Now, thank you from my side, and of course, when we have different kind of durability and sustainability issues on our desks all the time, next there is my colleague Asmo who will continue with these conditions and guarantees and so on. So thank you from my side.
Okay, thank you, Harold. And so my name is Asmu Nieminen, and welcome to this webinar also my side. And as Harold mentioned, I work in SSAB Europe Technical Customer Service Department, and my responsibility area is Finland and Baltic countries from a point of view of color-coated steel materials. My part of the presentation is divided two parts, and its first part deals with SSAB Green Coat's corrosivity, corrosion resistance, and UV radiation resistance categories. And its second part deals with the Green Coat guarantee policy and certain selection recommendation for construction use. As SSAB has more than 40 years experience in demanding weather conditions, and it means that more than 10,000 test panels have been exposed with salt water, snow, ice, rain, UV radiation, wind, and storms, and etc. SSAB's global testing facilities can be found at Bohus Malmön, Swedish west coast, China, Australia, Florida, Arizona, France, and Cayenne in West Indies. And those fields test those fields test mainly corrosion and UV resistance. On this slide is described climate or atmospheric corrosion rate with unpainted, same as zinc coated steel material. Those numerical values mean same as zinc thickness loss. So it's micrometers per year. And these areas are Jingjing, Jingjing industrial area in China, Brest, North Atlantic in France, Puhus Malmön, North Sea in Sweden, Harmaja, Iceland, Baltic Sea in Finland, Espoo city in Finland, and Ähtäri rural in Finland. The most demanding area is Jingjing, which is heavy pollute industrial area, and there the thickness loss is around 1.45 micrometers per year. And the lowest end is Ähtäri, which is a rural area, and there the loss is around 0.13 micrometers per year. So it means that climate itself means a lot. On this table, based on the standard Euronorm 129442, and there is categorized climates for the low carbon steels. These corrosivity categories C1 very low to CX extreme high are defined on this table for exterior or interior. As said, C1 there is no exterior definitions or interior either. There can be heated building with a clean atmosphere, and then C2 very low level of exterior pollution and interior, and their condensation can be occurred. C3 is medium, and it can be exterior, urban. Sorry, I didn't see so well. Uh, so C3 is the medium, and it can be the exterior urban and industrial atmosphere with low CO2 or coastal areas with low salinity and interior where is a high humidity and some air pollution. C4 is high corrosivity, and it means exterior industrial areas and coastal areas with a moderate salinity, and interior it means moderate sulfur dioxide, like as a chemical plants. C5 is a very high corrosivity. It means exterior industrial areas with a high humidity and aggressive atmosphere, and the coastal areas with a high salinity. Interior, it means buildings or areas with almost permanent condensation and with high pollution, like as sulfur dioxide. CX is same as extreme high, and exterior it means high salinity and industrial areas with extreme humidity and aggressive atmosphere, and subtropical and tropical atmospheres. Interior it means industrial areas with extreme humidity and aggressive atmosphere. This slide is more or less an attention or note slide concerning these corrosivity classes, especially this CX category. Standard EN 129442 defines the environments same as corrosivity categories, but it's good to note that the service life, but not the service life in those atmospheres. And CX is very aggressive and demanding atmosphere. It's very difficult to give any simple and universal recommendation to CX environment because there are so many factors which may affect on durability of the coating. Atmosphere can be so harsh that color-coated steel is not the right material at all. It is also good to note that CX is not a typical condition in European area. Then the corrosion resistance classes are C based on the standard Euronorm 10169 in 2022. And there the corrosion resistance category of color-coated steel is determined in natural outdoor corrosion test sites like as rural, urban, industrial, maritime, pollution and humidity and seafront environments. Requirements are shown in the table below. Those corrosion resistance categories are RC1 to RC5 plus, and evaluated properties are test duration per year. Average edge delamination with millimeters, damage on bent part, and degree of blistering, like as density of blistering and blisters size. For example, demanding for RC1 category is 1 year test period, and its delamination maximum 10 millimeters, and degree of blistering density 2 and size 4. And there are a certain visual standard how to estimate these blister size and blister densities. Then the demanding for this RC5 plus class is 4 years test period, delamination maximum 2 millimeters, and degree of blistering density 2 size 2. Not only corrosive salt compounds and humidity don't cause corrosion, so the long-term durability of a color coating is also strongly dependent on the UV and heat resistance of the coating. On this slide is told how RUV class indicates the coating's ability to maintain original color and gloss under UV exposure. These RUV categories are also based on this mentioned standard EN 10169, and when testing is made natural environment, the cumulative solar energy must be at least 4,500 megajoules per square meter per year. This kind of condition can be reached inside like as Florida and Arizona. The test duration is 2 or 4 years, depends on the UV resistance category. The artificial aging test under combined action of both UV radiation and condensation is carried out for the coating system categories RUV 2 to RUV 5 in Q panels UV chamber based on the certain standard. The test duration is 2000 or 4000 hours, depends on RUV category. And for example, category RUV2 means that the test period must be 2 years in natural exposure or 2000 hours under artificial UV radiation. Max color change can be delta E5 and minimum gloss retention 30%. Requirement for RUV5 is a test period 4 years or 4,000 hours under artificial UV radiation. Maximum color change can be delta E3 under natural circumstances and delta delta E2 under artificial UV radiation, and minimum gloss retention 80%. On this slide describes cumulative amount of the solar radiation globally on an annual basis. And roughly we can say that these 45 latitudes above, there is RUV2 category areas, and between latitude 45 to 37, there is a RUV3 category, and below latitude 37 there is RUV4 or even RUV5 areas. This slide is more or less summary for RC and RUV categories. So it's important to notice that the RUV or RC classes based on this Euronorm and corrosivity categories C1 to CX based on this certain standard are not equivalent. That's the good to note. And also this Euronorm 129442 defines the environment C1, CX, but not service life in those environments. So this defines the environments, but not the service life in those environments. Standard 10169 was made a revision, and a new updated standard was published in March this year. It's around now the one month old, or less than 1 month, I would say. Euronorm 10169 defines the testing times, 1 year in RC2 class, 2 years in RC3 to RC5 class, and 4 years in RC5 plus for the blistering and edge lamination in corresponding C2 and C5 corrosivity categories. Updated standard complemented with the new RUV5 and RC5 plus classes, and the criteria for edge lamination and blistering is same as in the old standard, but now the testing time is doubled from 2,000 hours to 4,000 hours in artificial test, and from 2 years to 4 years in natural outdoor corrosion and UV tests. Then the second part of my presentation deals with the Green Coat's guarantee policy and selection recommendation for the construction use. Green Coat guarantee admits up to 50 years technical guarantee on the steel and up to 25 years guarantee on the aesthetic appearance of the coating. Roughly, it can be said that the guarantee covers materials technical performance. That means no perforation of the product due to oxidation, and it aesthetical performance that the coating will not scale, crack, peel off from the product, and that there will be no any significant or uneven alterations in the color. SSAP can admit two types of guarantees named as a regular green coat European guarantee for corrosivity categories C1 to C3, and a project guarantee for the corrosivity category C4 to C5. This European green coat European coating guarantee is divided to zones. Zone 1 gives maximum 25 to 15 guarantee years depending on the color coating, and zone 2 gives maximum 20 to 10 guarantee years depending on the coating. So for example, green coat High-Arc and green coat Pural PT, 25 years in zone 1 and 20 years in zone 2. Boundary of the zones is roughly the 45 latitudes, and the minimum zinc quantity must be 275 grams per square meter in the separate steel material, so that the guarantee could be valid. This table tells the guarantee years for roof coatings by corrosion categories, and for example, the categories C2 to C3, the maximum guarantee years can be achieved to the separate coatings, and in the category C4 to C5, guarantee years are limited, and only project guarantee can be used for separate coatings. For example, maximum years for the category C2 to C3, and for example, to green coat Pural PT coating in category C4, it's up to 10 years, and in category C5, it's up to 5 years. And for example, these other coatings, which has been mentioned on the table also, ground BT, green coat ground BT, rough matte polyester, and outdoor polyester, we cannot admit any project guarantees if the corrosion category is C4 or C5. This table tells same information for facade coatings, and for example, green coat High-Arc regular and matte gloss and sign effect coatings, they can achieved 25 normal 25 years guarantee in corrosion category classes 2 to 3, but for example, these categories C4, C5s, we cannot admit any project guarantees. But when we compare to green coat High-Arc Max, regular and matte coatings, there we can admit a project guarantee in category class C4 up to 10 years, and category in category C5 up to 5 years. This is an example how to evaluate corrosivity categories in marine environment, and the above part of the table is an example from the Baltic Sea. And northern part of Baltic Sea and northeast from Malmö city belong to category C3. And 300 meters to 3 kilometers from coastline at Swedish west coast belong to C4. So there are no C5 or CX category areas in the Baltic Sea. The below part of the table is an example from a high salinity ocean like a Mediterranean Sea, and their C3 category is more than 10 kilometers from the coastline. C4 category 3 to 10 kilometers from coastline. C5 300 meters to 3 kilometers from coastline, and CX, so offshore areas with the high salinity. And as you remember, we don't recommend to use the coating in this CX, in any coatings in this CX environment or corrosion category. No, this slide is a general point for coastal and industrial areas. So if building is situated in coastal and industrial area where pollution together with the humidity and salts could pose a threat to the durability of the coating, we should specify a coating with the corrosion resistance category of minimum RC5 according this many times mentioned Euronorm AN 10169. On the next slides, there are some relevant questions for the designers concerning coastline and industrial areas. So in the case of the coastline area, then it's good to ask what is the planned service life of the building. So how many years? What will be salt content of the sea? What's the distance from the sea? How about the topography of the sea? Typical direction and strength of wind? Is there other buildings between the sea and the object? Is there a possibility that salt water may splash on the wall or roof? And what kind of inspection or maintenance program is planned? And or for the industrial areas, it's also good to ask what kind of chemicals will stress the coating. Is there hydrochloride, sulfuric, phosphoric, or acetic acid, or some other alkali, sulfur, ammonium, nitrate in the air? What are the contents of the hazardous chemicals? What kind of inspection or maintenance program is planned? And on this last slide is asked pay attention some certain points like the coastal areas, if the distance from the sea is less than 100 meters. Very heavy industrial circumstances, circumstances in which strong acid exists, for example, uh, more than 10% hydrochloride, sulfuric, phosphoric, or acetic acids, or other alkali, sulfur, ammonium nitrate, or other hazardous chemicals. Then the temperature, more than 100 centigrades, especially continuously, and the buildings in which is continuous high humidity and perhaps some chloride also in the inside air, like a swimming holes and spas and etc. So that was all in my part of the presentation. So thank you very much for the audience. So if you now have any questions, so you and I are ready to answer the questions.
Thank you, Asmo. There is actually one question from the audience. I think this requires a little bit more discussion, but maybe you can answer it shortly. Basically, the question is if those corrosion classes are just for the raw material or for the product as well. Well, I think let's imagine, let's say that well, for rookie products, for cladding products, etc. As you are talking, let's say for C4 materials, high arc max, let's say, okay,
Yes.
and we produce some Libertas or something like that, our product. So the maybe you correct me if I'm wrong, but if we produce Libertas, the same corrosion class applies to the product itself, and if as it says the Einers asks also if for perforated or tinsmith factory or building yard, for those I think the perforated, as always, we suggest that all perforated products should be powder coated only because all the
That's true.
inside areas are open to environment, so it's quite dangerous for those areas.
Mm.
So anything to add from that?
No, actually no. So I would say so. Of course, there are the risk points always if the material is perforated, and as you said, so is then it's the better to power coat, use the power coating, so that we could also to protect those perforated parts of the material.
Mhm. Also, another question: is it correct that if delta E is less than one, that I doesn't see the difference between two color samples?
Uh, no, roughly we can say so. But of course it's depends on the color. And for example, for the dark colors, we can say that the delta E1 is some kind of saturation point, and if it's if the color deviation is less than one, so then it's very difficult to see the differences. But if the color is very light or white, I would say, so then it's also the possible that this uh, limit point is less than delta E1.
Mm. And of course, it depends on the eye as well, I guess.
Yeah, yeah, correct.
Oh, it seems someone is typing. Maybe let's give it a minute. Maybe there are some questions, but it looks like we're close to the end of our time as well. But let's just wait if someone is.
Someone is typing.
Yeah, so
I
let's
can.
just give it a minute. Maybe someone has a question. Aesthetic guarantee 25 years, same for white and black colors.
Uh, Actually, they are valid all our standard colors based on our regular color maps, and there are white colors and there are dark colors. So I would say that then the aesthetical guarantee 20 years is same. So if if the coating is, for example, this green coat hierarch or green coat pural PT, which is admitted is for 25 years guarantee in zone 1, as I explained.
Mm. Thank you. Yeah, so thank you again, Asmo. Thank you, Juho,
Okay, thank you.
for the
Thank you.
presentations. Of course, thank you all for participating and listening, and hopefully you found this webinar interesting, useful, and informative. As in the beginning we mentioned, we will share the presentation and as the PDF. You should receive a link to download it in a couple of days. And once more, thank you, everybody. Have a good rest of the day and see you soon, I hope.